When they will communicate to each other, they will create a session, and this session has lifetime. This lifetime can be defined in kilobytes or second. Okay, so by default is here 86400 seconds, or we can say here 24 hours. We can calculator 60 multiplied by 60 multiply by 24. Yes, 86400. Okay, means when R1 is communicating with R2, it will create a security association with the peer, and this security association by default is 1 day 24 hours. In second is in front of you 86400 seconds, and for this session they will create a key, for example key 1. But next day what they will do, if they are interested to communicate with each other, then they will create another session. For that they will use key 2. Same for third day. If they wants to communicate, they will create another session. For that they will use key 3. So why they are using different keys? Reason is, if an attacker is able to find out that which key they are using, so what that attacker can do, that attacker can check our packets or intercept our packets. That is not as much as easy as I am saying, but if we will use a single key for entire communication for 1 month or 2 months or 3 months, so what an attacker can capture our data at the time of negotiation when they are involved, and that can find out that what is the key which is being used for the communication. But okay, if they started negotiation in the morning, and at that time attacker is trying to capture the traffic, and attacker has some packets has been captured by the attacker. Now attacker is trying to decrypt it or to check that what is the keys there. Along with the time, attacker can find out that what is the key. If at okay, when attacker will get the information and this is the key, and at that time we are using the same key, then attacker can intercept our packet. So to solve this problem, what we will do, we will not use or we will not configure SA for long time. What we can define in seconds. By default is 24 hour, and what we can do, we can define this session less than 24 hour. We can define, okay, the session whatever we will communicate, whenever we will communicate, we will use for 1800 second. It means half hour. Okay, when they are communicating for half hour session, they will use key 1. For next half hour they will use key 2. For next half hour key 3. So using different keys, we are increasing the security. Okay, again I am repeating. If we have configured as a lifetime 1800 second, it means that when the VPN peers will communicate to each other, they will create SA for half an hour. For half an hour they will use key 1. Same for second half an hour they will use another key. Now what is the advantage of this sort security association? It means that when attacker will try to capture the traffic, that requires some time to find out that what is the key. But this short span of time is not enough for attacker to decrypt it. And when the attacker will be able to decrypt it, for example, to decrypt the key, attacker needs 1 hour. But when attacker will decrypt the key, you can see there, if attacker needs 1 hour, then at that time key is not valid. For that, we are using another key too. To decrypt this key, again it requires 1 hour. When it will, attacker will find out at that time, it may be possible that we are using another keys. So what is anti-replay here? Anti-replay means that if your data will arrive late, then it will be considered as alter and it will be dropped. Anti-replay can be defined in kilobytes or second. If an attacker is able to find out the key, for example, key is 1, and when attacker will send the data to any branch R2 and R1, and at that time we know very well key 1 is not valid at that time. Which key is valid? Key 2 or key 3 is valid. So that packet will be